Exponential Growth and Decay Applications Teacher Talk. Number 1, Jen finds an investment that pays 10% interest and compounds semi-annually. Sammy finds an investment that pays 9.8% and compounds continuously. If they each invest $1,000, who will have more money after 5 years? So in this problem, I see that we have two problems that we're solving. We're going to figure out how much Jen will have after 5 years, figure out how much Sammy will have after 5 years, and then say who has the most. So looking through here, I notice that my principal for both of them is going to be $1,000. The time for both of them is 5 years. Jen's rate is 10%. Sammy's rate is 9.8%. And Jen has an N value here. Semi-annually means twice a year. So N will be 2 for Jen. Let's start with figuring out how much money Jen has. Here's our information for Jen. Since we're compounding semi-annually, we're going to use the periodic investment equation. We will plug in 1,000 for P, plug in our rate, plug in our N value, and T. When we plug that in our calculator, we find out that Jen has $1,628.89. Next, for Sammy, we see that Sammy is compounding continuously, so we're going to use PERT. Plug 1,000 in for P. E is just a number, so use E, our rate, and our time. Plug that all into our calculator, and we get that Sammy has $1,632.32. So, in the end, our final answer is going to be Sammy, because she has the most money after 5 years. Number 2, you take a 325 milligram dosage of ibuprofen. During each subsequent hour, the amount of medication in your bloodstream decreases by about 29% each hour. Write an exponential model that gives the amount Y of ibuprofen in your bloodstream T hours after initial dose. Estimate by guessing the value for T, how long it takes for you to have 100 milligrams of ibuprofen in your bloodstream. First, we need to decide if we're going to use our growth formula or our decay formula. And since I see the word decreases right here, and that makes sense, right? You take ibuprofen and you don't have more and more in your body. The longer the time goes, you have less and less. So we're going to use our decay function. Now we need to figure out what the values for A and R will be. A is our initial amount. It tells me that we have an initial amount of 325 milligrams. And R is the rate that we're decreasing. It says 29% per hour. So we have 325 times 1 minus 0.29 to the T. We can simplify the parentheses there, and now we have the model Y equals 325, 0.71 to the T. Next, what we're going to do is we're going to estimate how long it takes for us to only have 100 milligrams of ibuprofen in our system. And we're going to just do this by guessing values for T. So get your calculator out, plug some numbers in for T, try 1, try 7. Remember, this is the hours that the medicine is in your body, and we want to just know how long it takes to get to 100 milligrams. So we want to know when you get pretty close to getting out 100. I'm going to start by testing 5 first. I just kind of picked a number out of thin air, to be honest. So if I plug 5 into my equation, put that in my calculator, I get approximately 58.6 milligrams, which is obviously way too low because I want to know when we have 100 milligrams. So the next question is, should I try like 6 or 7, or should I try 4 or 3? And the answer would be I need to go smaller, 4 or 3, because if it's in my system for longer, 6 hours, 7 hours, I'm just going to have less and less. So maybe next I'll try, 3. Okay, when I plugged in 3 this time, I got 116.3 milligrams, so close, not quite there. Next, I'm going to try 3.5, and we get to 98 milligrams, which is pretty close. So I'm just going to approximate about 3.5 hours after taking this ibuprofen, we have 100 milligrams left in our bloodstream. In future concepts, we're going to find a way to take an equation like this and we're going to be able to actually solve for t using some different functions we haven't seen before.